Hello, welcome. Hope you had a good morning tea. By now, as developers, I'm hoping we've got this concept of unit testing down. As you've been writing unit tests, you've been focused on simplifying your code so you can test it. And that included learning about things like dependency injection, or at least designing your code so you can overwrite those key external dependencies so you can test your code with small, simple, fast tests. And throughout that journey, we've learned a lot about our systems and how to model it for testing. We've probably also discovered new behaviors or new approaches to designing our tests. On the other side of the testing realm, we have the system integration test. And that's usually an end-to-end test and is characterized by script recorders that tend to be quite fragile, and an area that very few organizations out there have been able to automate in any sort of significant way. My name is Colin Bauer, and I'm from Canada, and I'd like to thank Telerik and Microsoft for bringing me out here to share with you a little bit about this area that lies in the middle between that system fragile end-to-end tests and these smaller unit tests you write, and this is called integration testing. When I talk about integration testing, this to me is about getting two or more components, usually across tiers in an n-tier architecture or across service boundaries, and making sure that they interact in a way that makes sense and is meaningful. But it's not just about crossing a barrier such as HTTP or a file system or off to another service. It can also be within your code as well, testing how two components can interact together within your code. And so what I want to do today is show you some real-world examples from code that I've used with various clients to demonstrate some of that. Now, before I go too much further, I'm curious how many people out there today are testing at what they consider an integration level in an automated fashion. And okay, excellent. So there's a good chunk of you out there. So I'm hoping today you can share some of the horror stories, the things that you've encountered. I've got a couple of T-shirts, thanks to the folks at Telerik, to give away, along with a license to the Just Mock and Just Code products as well. So we'll figure out how to give those away during the more important section of this talk, the code section. So when we talk about integration scenarios, like I said, what really comes to mind are a couple of key areas of risk. And risk is kind of a key aspect in any test design, not just integration test design, but testing done right doesn't mean you have 100% code coverage. No matter what your manager will tell you, that the metric must be 100%. It's really about trying to go after those areas of high risk. And so when I think at an integration level, things that have burned me in the past is always the question that I'm answering to myself as to where a lot of that significant area of risk is. Good example, or a mapping. Somebody makes a change to the database schema. Did that propagate into the code? Or vice versa. Somebody makes a change to their domain model. Did that propagate itself down into the database schema? And did it do so correctly? Is anybody doing SQL database level unit testing, like T-SQL unit testing? I see one brave soul who's attempted that. That tends to be a scenario out there that's very rare, and so I want to kind of share with you an example of how you can potentially overcome that through at least a code level approach to that. The other side are things like contract and service behaviors. So if you're interacting, for example, with a payment gateway, it's kind of important to know how it behaves. One of my past startups was in the music industry building websites for rock stars, and when we go on sale at rogerwaters.com, the last thing I want to do is fail to make that sale because I didn't recognize a New Zealand phone number format or a particular state. And so from an integration perspective, I want to make sure my service behaves as I would expect it, not based on the documentation that I've read, but by actually trying to prove that out. And so, those are really, really important boundaries to test. And so we'll go through some of those in just a second. When it comes to writing integration tests, though, the principles behind them are pretty much the same as writing a unit test, in the sense that a good integration test is easy to set up and run. It's not 5,000 pages of code to get the environment set up. It's easy to maintain, it makes sense, and in terms of, kind of does this test make sense? Again, that's a little bit of a qualitative judgment, but after you've written your test suite, if you step back and you see value in every one of those tests, they probably make sense. If you see a lot of duplication, it's probably time to remove some of those tests. And finally, it's trustworthy. You know that it can run anywhere, anytime, and prove what it is that you're trying to test. I'm going to show you some examples of what I consider trustworthy tests today. The only difference, I think, between what I consider a unit test and an integration test from a principles perspective is the quick-to-run piece. The quick-to-run piece is something that on an integration level, you might have to set up a database or set up another service. And so your tests are going to run a little bit slower. And so I probably wouldn't run my integration tests, let's say on my commit build, if I'm using a build server like TFS or TeamCity and such. I'd probably run it as a secondary build that only if my commit build ran and all my unit tests pass, I would then run my integration tests. The key, however, though, to integration testing, and remember this slide, we're going to come back to this after you see the code because I think it will make a little more sense, is managing your dependencies, or what I call fixtures, and their existing and current state. And this is the hardest part to work with when you're working with two or more components that are working together. The component that you're testing against from your kind of source component, if you will, you need to know its state. You need to be able to control its state. And so we'll take a look at examples of things like user mode instances of fixtures like SQL local DB and how to use that to manage state. And then we'll talk a little bit about some of the challenges of the shared scenario where you got a shared service. Let's say you've got a big enterprise reporting service, and it's some tens of thousands of dollars per node, and you can't get a license to install in your local dev box. And so there's a shared instance that the entire dev team shares. We'll talk a little bit about how to deal with some of that, and we'll give you some code at the end. In this case, I was using SQL reporting services, even though that's not tens of thousands of dollars a node. It was just good enough to show that example. But more importantly, when it comes to managing those dependencies, you've always got to be able to be in control of the state. And so, the best way to kind of dig into that is to get out of these slides and let's get into some code. Now, as I'm coding here, what I want you to do is take a look at this code, and I want you to understand the approach I'm taking, less the technology. So I'm going to show a little bit of XUnit. So whether you use XUnit or MBUnit or MS Test as your test framework, that shouldn't matter. So, hang on, my laptop here went to sleep. Give me 2 seconds. Whether you're using Entity Framework or in Hibernate or Open Access as your ORM, it doesn't really matter. What matters here is really the concepts as to what it is that what we're doing. So I'm going to start off with a scenario where I've been handed a new service. In this case, this particular service is a translation service that allows you to translate English to French, Spanish to Portuguese, and so on. And so I want to write a couple of tests around it. I've read the documentation, but I know, like any good developer, the developer on the other side probably wrote the documentation after they wrote the code at the very last minute because somebody said we had to ship developer documentation with our API. So I'm not going to spend a whole lot of time reading their documentation. It's boring, it's bland, it's very sterile. What I really want to do is exercise their service and make sure it does what I want and to help me understand a little bit about how it behaves. So I've got my core library here that has a suite of services set up. Here's my translation proxy stub that they've given me. We'll come back to that in a little bit. That's not really all that interesting. I'm going to come over, though, to my integration test project. And the first thing we're going to do is go ahead and add a new test class so that we can go ahead and start testing. So let's go ahead and do that, and we'll call this translation. And I like to call them facts, and that's more of an XUnit-ism. You can also call it tests as your class. It is really up to you as a team as long as you decide on a nomenclature. So this particular library has really one call. It's called translate, and you provide the text, the from, and the to. And so as I'm designing my integration test, I'm actually discovering the service and the behavior. And the first test that I often write when it comes to testing service contracts is make sure the happy path works. For those of you that don't know what the happy path is, or it was something I learned from actually a bunch of QA testers, and this is the best path from from the start to the end of your system that exercises all the components of your system properly. So we're not dealing with nulls and all these kind of weird, like the service down error. We're just trying to make it work. And so I'm going to go ahead and write my very first test. In this case, I'm going to say translate returns French salut for English hello. So a nice clear test name. I'm not going to be too shy on the content of or the length of the method name, because quite frankly this is just a test class. It's not production running code, and what I really wanted to do is make it clear what my intent is here of actually testing this. And so I'm going to go ahead and set up my test. And so integration tests and unit tests, in my opinion and my experience, should follow similar sorts of patterns to what you're used to in the unit testing world. So arrange, act, assert. And the reason that pattern's interesting is because it separates out all the things I need to do to set up the execution of the test and tries to make very clear what it is that I'm testing at the end. And hopefully that matches up with the name of my method. So in this case here, I'm going to go ahead and get some text here, and I'm going to say hello. And I'm going to say it's coming from the English language, and it's going to the French language. And what I'm actually doing is I'm expecting it to come back as salut. So now on my act side, I've gone out and I've cursed through the documentation they've given me for this translation API, and it says a bunch of things. But you know what, like any good developer, I'm going to put the documentation to the side. I'll read the manual later or treat it as reference. I'm going to dig right into this particular API. And so let's go ahead and do that. So I'm going to bring up a translator container, which is the actual name of the object. Again, not exactly the most friendly name from a development perspective. So let's go ahead and spark up a new one. And I see right out of the gate here, I'm going to need a service route. So let's go ahead and put those out. So I'm going to go var service route is equal to new URI. I'll fill that in just a little bit. And then I'll go ahead and do container dot translate. And then there's my parameters there, text, to, and from. And when I read the documentation, I have to always call execute, and it gives me back an IEnumerable, so I'll just convert that to a list and ensure the actual behavior comes back. And so what I need to do is actually get that back, though, as the actual. I need to spell actual correctly. Now I need to assert that my expected, my actual work. And so let's say actual, and then, so at this point here, I'm thinking to myself, I can go ahead and do the very bland assert equals, not equals, and so on. But again, I want my test to be readable. I want anybody who looks at this, who doesn't really understand the framework, to say, what exactly is going on? And I don't like those assert class for that. I prefer something a little more fluent. And so there's a great little library, and I'm going to show you a bunch of these little libraries throughout that I've come to learn and love in all of my testing, not just integration testing, called Fluent Assertions. And so what this allows me to do is go ahead and test that this collection here only contains, actually I'll go ahead and just resolve the references here to, oops. So this should only contain items where that is equal to the expected result. So here I'm getting basically a collection here where I'm expecting really one item, and that item should be the expected. So let me actually I'm going to minimize this here because all the important stuff is over here. So something a little more readable. I should get back a collection. It should have only one item, and that item should only be the expected item. So now I got to come back here and I got to plug in these particular values. I've gone ahead and saved them off to the app config, and we'll come back to this app config actually in just a quick second here, because that's a key part of managing fixture state, is to try and make my code somewhat flexible. So we'll go ahead and copy that off, put that into my URI, and let's go ahead and run the test. So let's build it first, make sure everything's good. Build started, cross our fingers, oops. Sorry, this is .text. Sorry, so it actually returns me not a collection of string, but a collection of the object itself, or a particular object, translation object. So we'll go ahead and run that test, and hopefully all goes well. My internet connection is happy. And we've got a little bit of an error here as we go ahead and use this test. We forgot to authenticate. And this is, typical of anybody exploring a test for the first time. this was somewhere around section 17.6 in the documentation. I completely forgot about that. So I'm going to go ahead and actually look that up in the documentation and learn, oh, I've actually got to add a little bit of a header, and they've made that a little possible here through the translation container by exposing a credentials property. So that one actually happens to work off the network credential API, not exactly the most beautiful API per se, but it takes in the API key through the username and password. And so again, I'm going to just go snip this value out of the config, and we're going to come back to this config thing, because again, this is kind of key in terms of making more maintainable tests. Now let's put this back in the translation container. Oops. It's username and password. Get that on the right side. Go ahead, build the solution. Oh, sorry. What did I miss? Oh, yep, sorry. Yep, that's right. It's a property, and then it's supposed to be over there. All right, so let's go ahead and try and run that test now, and all should be good at this point for the test. So I've written my first service test where I've gone and explored how the service itself works. Oh. Expected collection only contains items, but found text salute does not match. Oh, did I? Oh, I did. There you go. Hey, my test worked great. Sorry, I am from Canada, but it doesn't guarantee that my French is any good. So let's go ahead and run that test again. And hopefully, cross our fingers, we've got our salute spelled correctly, and voila, we've got a good test. So, what I did here really is this was kind of my fastest way to actually learn how to use this API. And so my point here is, this is not a mandatory function, but this is probably one of the better ways to actually learn how to interact with your various services here. So I'm going to probably refactor this test over time, and I'm going to think about other tests that are probably a little more useful to write. And so I'm going to I'm thinking in my mind about all the various tests that I want to write, and whenever I think about tests, I always think about the positive, the negative, and the fault tests. And this is something I do for both unit testing and integration testing. So positive is that happy path. Versus negative is things like, if I've got a true value, how do I get a false value kind of out of the code path? And then the one that I'm really surprised a lot of developers don't spend a whole lot of time testing is the fault path. And that's, how do I break stuff? So what happens if I provide nulls or empty strings, or I forget I have an invalid parameter? How does my service behave? And so we're going to explore, actually, as we look at the ORM scenario, a scenario where you might actually need, it'd be important to test that, because we all make assumptions about how our framework behaves. Unless we put a little bit of test behind that to prove that, sometimes we forget that. But before I go ahead and write my next test in this particular scenario, there's a couple of things here that I probably want to do to this test here. I'm just kind of looking at this before I leave, and I say, I've got some hard-coded URLs here. I've also got a hard-coded set of credentials. That's probably not good from a long-term perspective. And so in this particular test framework, it supports the notion of fixtures. And so fixtures are really saying, I've got an external dependency, and the fixture really contains all the meat and potatoes around managing the setup and teardown of that particular dependency. So I want to introduce the fixture here, even though I'm not going to write the second test for this exact example, because we're going to talk about that in a lot more in just a second. So as I look at this test here, I'm kind of curious, what are some of the, can somebody name one of the components that you'd tear out of this test and move into, let's say, an external fixture class? URI, who said that? Sorry, over there. Awesome. There you go. Great. So yeah, as you start to look at things like URIs, passwords, these are things that you don't want to be in your test, because it actually has nothing to do with the test itself. Your test should be arranging, acting, and asserting, not setting up all these various external dependencies. And that's really where the role of the fixture comes in. So I might go ahead and create a class called translation fixture. And in XUnit parlance, it's just a regular class. In other frameworks, they call it different things, but the concept is still the same. This is my container that manages my external service dependency. And so I'm going to go ahead and create my translation fixture, which manages my translation service. And at the end of the day, I want to go ahead and expose the translation container. So that will be the key emphasis of it, which is exposing that. And the pattern I like to use with any of these, and this is just out of experience, is actually using lazy loading results, because for every test, you don't always need all the fixtures. So in this case, I'm going to go ahead and take advantage of something that sits in the .NET 4.0 runtime, which is the lazy operator. So I'm going to go ahead and create a container equals new lazy, and we'll go ahead and create translator container. So I'll move that off into a static method here. Public, no, we'll make that private. And actually, I'm going to move this to private as well. And static translator container, create translator container. And this is where I'm going to move a lot of that setup junk, if you will. So let's go back and look at our test here for some opportunity to move a few things around. So I'm going to extract out all of this, and so my test can really focus on just running the actual method here. Let's go ahead and pop that over here, and I'm going to say return container. And let's do a little bit of renaming here just to clean up. Call that result. Call this var. And I'm also going to go ahead and take out these URLs, because this is one thing that, again, when you start looking at tests and what makes tests fragile is things like hard-coding test server names. These are things that shouldn't be littered throughout my code, or user IDs and passwords. Wherever possible, I want to go ahead and pull those out of something like configuration. So if I go and try and pull up the configuration manager and go into my connection strings, and I'll go translation services, I believe is what I called it. I'll double check that in a second. That'll contain my URL to my service route. The other one I'll go ahead and get is my API key. And so what essentially I'm doing is I'm building here a reusable fixture that can be used in a number of different places. And again, this gets even more handy as we go ahead and look at the database scenario in just a second. Translation services key. I think that's just a straight up text value. Oh, I got a typo. All right, let me just, I'm going to do the safe thing anyways. I'm going to cut and paste that key name from the app config. There's nothing like pair programming with a group of awesome developers, let me tell you. All right, let's go ahead and make sure that's good. All right, so now in my, what I get to do here at my higher level here is I can go ahead and use that fixture. Now again, XUnit as a test framework, and for those of you that haven't explored anything outside of the MS test realm, I really encourage you to look at frameworks like XUnit and MBUnit. There's some really neat things that they're doing. Even NUnit is actually still alive and kicking for those of you that haven't used that for quite a long time. But let's go ahead and implement this particular set of tests here. So what this does is XUnit manages the creation of my fixture and then passes it in on every test call. So I'm going to say translation equals data, and we'll go ahead and introduce here a backing field, called translation. So what this allows me to do here is go translation dot container. Oops, I thought I passed a container back. Oh yeah, that's correct. Yeah, so there we go, translation container translate. So now what I've done is I've gotten out of my tests here all of the noise around setting up my dependency. That's all handled in the translation fixture. And I've got a nice clean test that actually kind of looks like a unit test in a lot of ways, where I arrange, act, and assert. And so, integration tests don't need to look all that different from what you're used to today in the unit testing world. The key is, how do I make sure my dependencies get set up and get cleaned up appropriately? And so let's actually look at something that's a little more complex. This is an example of interacting with an external service. In this case, there's not a whole lot to clean up. But I've got an example with the database side of things where you actually have to do a little bit of cleanup, and I'll show you some of the technology around that. So let's take a look at the next scenario, which is database migrations. So this particular project has a package called Fluent Migrations, and that's responsible for setting up the database schema. And so it creates tables, it goes ahead and changes tables, and goes ahead and makes all my various changes to my database schema over time. So when I go from version 2 to 3, Fluent Migration is responsible for moving my versions of my database schema up the realm. And this has worked out great. And so if you've worked with things like Active Record, for example, on Ruby, you've been used to this pattern. But I got to say, as a developer, this has worked a whole lot better than waiting for a DBA to write a diff script, roll that, do their own testing on it, roll it to production. This allows us to test that upgrade scenario very, very rapidly. But one of the things that nobody ever thinks to test, at least until we need it the most, is how do I actually roll back? And this is something that's burned me in production using this tool, because each one of these classes here, they have an up and a down. And so the up makes the change, in this case for version 2, where it says, go add this particular column, and down goes ahead and gets rid of the column. But the thing is you don't, as part of a deployment process, you're always going up. Rarely are you ever going down. And if you are going down, it's because something went wrong and you really need to roll back. And so using this sort of approach and technique, I've been burned a number of times with making sure that the actual downgrade process works, that I've now started to write an integration test that actually doubles as both a upgrade scenario from scratch and a rollback scenario back to scratch. So let's go ahead and write that particular test. So we'll go back to our integration tests here. And by the way, all this code will be available on GitHub with all the libraries I use, so you can see it in action, including the fixtures. So, because I don't want you to really focus on Fluent Migrator and all the specifics of it. It's just going to, otherwise we'll be here for quite a while you scroll down all the various commands, especially when we get to Hibernate, which is very verbose in ways. So let's go ahead and create a set of migration facts. And so the very first fact that I absolutely love to write in the migration side of things is, can I roll back? So let's think about all the different things that we need to do to test rolling back. There we go. So I need to be able to count the number of tables, count the number of tables in the database to get my starting point. Need to be able to deploy the schema. I need to take a midpoint checkpoint. I need to roll back the schema. And I need to get an endpoint. And then I need to compare that the start point is equal to the endpoint. And then both of those are less than the midpoint. So to make sure the actual rollout worked, I'm going to make sure that it actually added some tables. But more importantly, what I started with and what I ended with looks about the same. And so as you're thinking about this, you're thinking to yourself, okay, I got to get a database set up. I got to get the schema out there. There's a couple of things around that external dependency I need to get working. Well, up until this point, up until about the 2012 timeframe, one of the things I absolutely loved was SQL Express and their user mode instance. It allowed me to get a full database server without having to have a sysadmin or a DBA go set one up and do all their fancy stuff for production-oriented systems. In SQL 2012, they shipped something called LocalDB, which took that user mode instance and packaged it right into the, to be able to run alongside your database as an embedded database. So let's go ahead and new up a database. So it's called service-based database. I don't know why they picked that name. I'm not going to argue that particular point. But I'm going to go ahead and create a database.mdf file in my integration tests. And this, I'll just escape out of the wizard because I don't want the wizard or any of that other stuff. This effectively is a blank database. And when I go ahead and run, I can go ahead and connect to this database with a particular data source key here, localDB / an instance name, in this case v11, and attach right to the database file name. And I get a fresh new database on a database server. It's fantastic. And when the integration test stops and it shuts down, that server goes away, kills the process, releases the locks on the file, and I'm off and running. So it's like setting up and tearing down, and I get it all for free. And not only that, I'm going to actually have the database itself copy always to I'm going to make sure it always copies to the bin file, so that every time I rebuild to do another test run, it's just going to reset what was there. So I don't need to worry about cleaning up after I'm done. The next test run is just going to rebuild and replace that file. And so this is a great way to manage fixture information and state by just saying, if I want to get back to 0, I just rebuild the project and bang, I'm back at 0. So let's go ahead and get started by rolling out that starting point. So the first thing I'm going to need to do is get a connection to that database so I can go ahead and get the starting and end count. So this stuff I'm not going to, again, this is just standard ADO.NET, SQL connection, and then I'm going to need a connection string. And then at some point I'm going to need to do connection.open. And let's let just code go ahead and get those dependencies all figured out, connection string, and I'll go to configuration. So I'm thinking a little bit ahead because, again, this is a configuration value. And so I'm going to kind of preemptively or prematurely optimize just a touch here. And I'm going to go ahead and put the connection string out into a variable. Normally, I would actually go ahead and just shove it right in there. But this one, I know I'm going to use the connection string twice in just a moment. So I'm going to stick that in a variable, open up my connection. Now, the first thing I need to do is go ahead and select the starting count of the tables in the database. Now, I'd love for you to sit here and watch me type ADO.NET, but I'm just going to actually cut and paste this little snippet in here. And I'll go ahead and show you we'll just walk through it because it's the exact same call. There's my starting, midpoint, and rolled back count. There's my 3 variables there. So all I'm doing is I'm opening up a connection to the database, and I'm calling a select count from the information schema.tables. This is as best as I could determine, because when you Google, how do I find the number of tables in a database, you get about 10 different answers of places to check. As far as I can determine, this is the official latest way to do it on SQL 2008 and newer. If you're DBA, I'd love to chat with you offline about if that's true. But this will go out and get me the number of tables in my particular database. It passes along the command itself and the transaction, which, by the way, again, using a package like an Hibernate Profiler or Entity Framework Profiler, I learned you always should be wrapping yourself in transactions. Implicit transactions aren't very good. Another story, another time. But now I need to go ahead and migrate the schema. Then I'm going to need to go ahead and do another count. So let's go ahead and we'll just borrow this code here for just a quick second here. I'm going to do it, and I want to do it in another transaction. I don't want to share the transaction because I really want to make sure that I get a fresh value from the database, nothing flushed or nothing cached. And then I'm going to need to go ahead and roll back the schema. And so we'll go ahead and get one more count. Oops. In this case, rolled back. All right, and then I need to go ahead and compare. Now, when it comes to comparing, ideally, it's just a straight sort of starting count dot should be the rolled back count. In this case, I'm actually going to say -1 because something I've learned with using Fluent Migrator is it always leaves this version info table hanging around. So I'm going to just put a little comment here so people know why I did this. I'm going to say the version info table kicks around. And this is how it controls which version is actually on. And then I also want it to be, I'll say .and be less than migrated count. So let's go ahead and just clear this out so you can see what I did here. So I've basically said that the starting count should be the rolled back count -1, so account for that one extra table that gets added. And it should overall be less than the migrated count. Now, I could get more specific here, and actually, if I knew how many tables my code actually generated or my migration actually generated. I could put an actual hard number in here, but I find it's not really valuable to get that specific. The purpose of this test is just to make sure I added stuff, and then when I took it away, it actually all came away. It's not important that it added 10 tables or 15 tables or 20 tables, because the whole point of this particular test is, can I roll back? Okay, and that's, when you're really working on tests, try to understand and keep a razor-sharp focus on what it is that you're trying to prove. Don't try and prove the entire world. Prove one point. And so this should be a very clear, this is my assert. So now I actually need to go and do the magic of migrating and rolling back the schema. And unfortunately, this session is not on Fluent Migrator, but it is an awesome tool. So I'll just kind of briefly drop in the code and show you the code and tell you a little bit about what it's doing. So the very first thing I'm going to do is I'm going to migrate the schema. What this is basically doing is it sparks up a migration announcer, which is just a debug tool, if you will. I'm just going to put it down at the bottom here. I've just got it actually outputting to the debug console. I'll let it resolve types. I was talking about system. I'm talking about system.io. Great. So it sparks up a migration announcer. And so this is just going to help it output all the debug messages and things like that. I like that on the debug console on tests so I can see what's going on. And then it's going to go ahead and the runner. The runner really is a set of parameters that you need to go ahead and provide it. And the core assembly is betterintegrationtest.core. We'll come back to that particular one in a second. So you're connecting to a SQL server. Here's the connection string. Here's the target. So I want you to operate against all the migrations that live in bits.core.dll. And here's a little parameter that I'll talk about in a second, and then go ahead and run the execution. So by default, Fluent Migrator's behavior is always migrate up. So if you don't tell it otherwise, it's just going to try and move everything to the latest version. And so by excluding any sort of thing about migrate up, that's exactly what it's doing. I've also passed in just an application context, which is just a state bag or a request bag that gives you a variable that you can pass around. And this is useful when I've got migrations that require things like full text index. Well, local DB doesn't support full text index, so I have it just check this variable and say, hey, if you're doing it on local DB, skip over the full text index parts that you can't do anyways. But that's actually purely optional. That was something that was useful in a particular project and just a habit I've carried along. So what this will do at the end of this command is make sure that my database is running the absolute latest version. Now the neat thing is the rollback is pretty darn similar. So to roll back the schema, in this case I'll just reuse the announcer, but I do need a new runner because we're doing a different operation. So what we're going to do is we're going to go ahead and roll back the particular schema here by telling it this time, roll back. So I'm going to say task is to migrate down, and the version I want to go to is 0. All right, and so this time I'm just going to rerun it, and we'll go ahead and work its magic. So far, does that make sense? Cool. Let's go ahead and build our tests. Let's cross our fingers and hope that all of our developers were on top of their... it got rid of my using Fluent assertions. All right, let's close that off. So let's go ahead and build that up. Let's go ahead and run my tests. And if all goes well, I should be able to roll back. And bang, I've got an error. So this was the thing that, this shows me, where I've actually got a problem in one of my down migrations. So it was trying to roll back version 4, and it had a problem. It tried to say that, hey, hang on, UX name is not a constraint that I can drop. So there's actually an error in my code. It rolled forward perfectly fine, but it couldn't roll back. And this is actually, what I found this one particular time where we ended up writing a test for this, is I went and fixed this error. And in this particular case, I've actually purposely put that there just so you can show you that these things happen. So I'm going to go into my migration number 4. And in this particular case, it was actually supposed to delete an index, not a standalone unique constraint. Let's go ahead and rebuild that. And we'll go ahead and rerun. But I spent probably a good day going through and fixing various down migrations that developers had written thinking, oh, this will probably work. but nobody had bothered to test. And so this test, once I wrote it, ended up saving my bacon because it was allowed us to actually fix a botched deployment in production because I knew I could roll back. And so it was, again, testing that, what I wrote in code and my database layer and making sure everything works well together. All right, so the next set of database tests and the ones that we'll spend a little bit more time on, or more interesting anyways, is mapping tests. And mapping tests are really interesting because they tend to be very, very error prone. Because you can go in and you make changes to the database schema as a DBA, a random business analyst, and not really understand what you're doing by renaming a column, deleting a column, adding a column, changing constraints until the app blows up. And then you as a developer get a phone call and say, hang on, the app blew up. So what I always like to do is write some tests to make sure the schema that I'm working against actually works as expected. And so I like to do that on a table or on a map-by-map basis. So in my particular case here, I'm using Fluent and Hibernate with their code-based mapping. You could be doing this with Entity Framework as well, using their code first or any other ORM. This isn't specific to the ORM. This just happens to be what I use. And so I've got a map here where I want to test a couple of aspects of this map. So let's go ahead and write some tests around that particular map. So let's go call it task map facts. So the very first test that I want to write, and this, if you're using an ORM, and I'm assuming everybody's using an ORM, Entity Framework, and Hibernate, something else? Cool, a couple of you out there. So one of the first tests that I'd like to always verify and make sense here of is that can I persist the entity, entity to the database? That's probably the one test I'd say if you've got any ORM out there for every map, there should always be a test that makes sure that the database schema and the object and the mapping in the middle, all three of those things line up and I can write and then pull from the database. Really, really simple test. Show you how to write that in a second. The other thing that I might want to try are things like custom type conversion. So in this particular case, I've got an enum conversion, but I might have written something that does some handling around geocoordinates in the new system.device geocoordinate class or around date time handling. That's a really big one if you're working on international apps is, the date that comes out of the database, is it actually marked properly as a UTC date or a local date with the right time zone? So I want to make sure that my conversion, that whole pipeline strung together, works accordingly. The other one that I probably want to test is actually my database, some database schema things in particular, things like constraints. So if I go ahead and insert a duplicate object, is it actually going to register the fact that it was duplicate? And this here is actually, in a lot of ways, I'm writing unit tests for the database through code because writing T-SQL unit tests is really hard. And this is a whole lot easier, for me anyways, as a C# developer. So I'm going to take advantage of this, and I'm going to build an integration test that's secretly a database unit test. And then finally, the other thing that I'm thinking about, and I'm thinking always about the pipeline of how does I get my domain object down to the database and back. I'm going to go ahead and prove that I've written a custom extension that ensures that the only valid objects get persisted to the database. So I'm using a package called Fluent Validation that all it does a check just before in Hibernate persists and says, hey, is this object valid? If so, by all means go ahead, and if not, throw an exception. But it's got some requirements to get set up, and so I want to make sure that the validator actually fires before it gets down to the database. And again, that's a case where I've been burned in the past where I forgot that one little bit of attribute that turned that turned the magic on the domain object, and then bang, everything blew up. So let's go ahead and take a look at a couple of those tests in action. All right, so the first one is the persist entity to database. So I can persist entity to database. Again, naming standard, I'm going to encourage you to come up with something descriptive, but not overly verbose. So what are the couple of things that we need to do here? We need to actually create an entity. I need to create a database connection. I need to roll out the schema. Oops. I need to persist it. I need a new connection. I need to retrieve it. And then I need to compare. All right. So creating an entity, that's usually pretty easy. Although with more complex entities that might have tens or 20s of properties, what I don't want here in this particular integration test is a big long new string. I don't care what the values are, just insert some random default values in there. And so I'm going to actually take advantage of a little library called nbuilder to go ahead and do that. I'm going to say, go ahead and build me a task. And IntelliSense is getting in the way. And I just want one. And so go ahead and build that. And we're going to change these options a little bit later. But what's nice about nbuilder is that it creates me entities with all the default values populated with something. And in this particular test, I don't care whether the ID is 1 or 5 or 10. I just want a value in there. So I'm not going to waste a lot of my time in my code initializing all the various properties of my task object. The next thing I'm going to do is go ahead and create a connection. Now, for those of you who had the pleasure of using and Hibernate, and I say that tongue-in-cheek, creating a connection to the database involves, oops, sorry. This one I'm not typing out because I guarantee you I will typo it somewhere. Usually involves something that looks a little bit like this mess on the screen. So in this case, it's fluent in Hibernate to try and keep everything into code. And yeah, there's a lot of stuff there. So I'm going to say var mapping assembly is equal to bits.core. Oops, semicolon. And connection string key. And we're going to, and this will show you the value if there's any reason as to why you want to move this out to a fixture, because this is really just noise in my test. All right, so I've got my connection, my session factory, and so that's what I want. Session factory. And so now I can go ahead and create a database connection var, using var session equals session factory dot open session. There we go. I got a connection to my database. Woohoo! So once I get my semicolon on the end. Now that I've got a connection to the database, I'm off and running. But hang on, I gotta deploy the schema, and I had that in that other fixture, or sorry, that other test class. You know what? This probably calls for a fixture. So before I go much further here, I'm thinking to myself, there's probably a database fixture, because a database represents an external service that I'm going to interact with. And I need something that can go ahead and manage the state for me. So let's go ahead and actually, before we go much further, go ahead and create that fixture, because I need to get up to the point where I can get a connection and have it use the latest database schema. So let's go ahead and do that. We'll go ahead and right-click and create a new class. Called database fixture. And we're going to go ahead and it's going to expose a couple of things. We're going to expose a method called useLatest database schema. And we're going to expose a method called rollback database schema. Which I can probably get rid of rollback. I'll just say rollback schema. It's a little less verbose. In this case, I'm going to actually say optionally give me version 0. So if I ever write a test that has to roll back to the last major version and test an upgrade, I can do that. So roll back to version 3, upgrade to version 4, make sure my data survived the upgrade. I definitely want that. And then the other thing I'm going to need is I need something that will give me an iSession factory. In this case, this will be a getter that returns session factory with a small s dot value, because I'll use a lazy. So there's kind of the public signature of my method. Now we got to go fill in all the guts to make that happen. So the easy part is things like the use latest and rollback. Let's go back to my migration facts here, and we'll start by going ahead and getting our migration piece here. So this is our latest code. Let's go ahead and copy that out and move that into my use latest. And we'll resolve the types. System IO, and I will need a connection string. So let's go ahead and do that as well. Sorry, I'm just kind of watching the time here. I'm going to go ahead and expose the connection string. Let's do this. Oh. All right, so there's our connection string. Then I'd go and replace this with my other const and whatnot, but that gives me enough to get rolling on this particular one. I also got to move my announcer across, so I'll go ahead and move that out of here. Put my announcer down here. Solve that type. All right, so I've got my use latest there. Let's put in my rollback here. So I can actually just cut and paste all these bits and pieces. And I can add in, if I'm lucky here, the 2 extra pieces I need, which is migrate down. And the version, good. So I've got use latest, I got rollback. So, you know, if I had a little more time here, I'd go back and just nuke those out of this particular block of code because it's no longer necessary. Actually, I'm going to have to, because I'm not going to, I'm just going to comment that out because I moved some things around. All right, so now I've got, I need to get my database fixture in here so I can say use latest. I use fixture, database fixture, and private database fixture, database, public set fixture, database fixture, data, public void. All right, database dot equals data. And just because all my tests are going to require it in this one, I'll just go ahead and say use latest schema there. So every time it runs the test, it'll just ensure that I'm always on the latest database schema. The other nice thing now is I'm going to move this junk across. Get rid of that. And I should be able to run instead database.sessionFactory.openSession, and then go ahead and test everything else. So what I need to do, though, is I need to go ahead and move that create session factory into the database. I'll do that rather quickly here. Oops. So I'm going to copy my entire fixture across here. So I've got my session factory. There's my create session factory there. So now if I go back to my task map facts, I'm good to go. Everything looks good. Now I go ahead and create that entity, drive it into the database, and go ahead and test it out. So one of the neat things that that they have in the Fluent and Hibernate in particular is the ability to go ahead and do this exact test, because they've realized that a lot of people did this. So they've written a class that does exactly what it is I'm doing. If you're not using in Hibernate or Fluent in Hibernate, I should say, don't worry. This class, I've actually written the exact same thing with Entity Framework. It does very much the same thing. In fact, if you actually go ahead and look at the code, and this is how I wrote the Entity Framework version of it. I just went in and looked at the implementation of it. And I can see here it goes ahead and saves out the first one, gets the identifier back, clears out the session, gets a new session, and then does a comparison of all the properties. And if it's false, throws an exception. I just basically copy that exact same pattern. So that will actually go ahead and do the entire piece there. All I need to do to remember at the very end is go ahead and roll back my transaction on my session, which I forgot to open. All right, so what I've got here now is I've got the ability to ensure that my task actually persists properly to the database. So I create a new one, go ahead and send it into the database. It pulls it out, compares the values, and if nothing matches, it goes out and throws an exception. So what's nice about this is as my domain evolves and my schema evolves, this test makes sure that I'm always in check throughout. And so this is the one test that I'd say that everybody should be considering writing out there. The other piece of tests that, just to kind of wrap up on, is ones where you need the database to be in a specific state, and it's more than just creating one entity. So you may need to test a situation where there needs to be 10 tables populated. They need to be populated in a certain order with certain sets of data. So for example, I may want to go ahead and test that I actually, if I violate a duplicate constraint, that I get the proper result out of it. So duplicate items, throws, constraint, exception. Because that seems reasonable. If I violate a constraint, I'm going to get a system.data.SQL constraint exception. So I'm going to go ahead and just get a new session. In fact, actually, I'm just going to start off with the basis of this here. And then we'll talk a little bit about how I get that database set up. So in this case here, I'm going to need an entity with a very specific condition. In this case, I'm going to say with the name set to need more caffeine. So in this case, I've got a database that says you can't have duplicate name values, just to test that. So I've created my duplicate value, but I need my database to actually already have that in place. And so there's a neat little package called NDBUnit that allows you to manage the data that's in a database, and it's agnostic of SQL or the various out there. It's got a variety of different providers. But the way it works is we start off by creating an XSD file to guide it, because it's actually just using the dataset technology under the covers to load the database. Let's go ahead and create, though, a database.xsd, and I'm going to go ahead into the Server Explorer, Solution Explorer. I'm going to turn in all files here, because I want to go look at that populated database, because I need the schema of a database that's deployed to be able to do this. And take the tables. Oh, we actually haven't, it rolled back. Oh, that's right. Sorry, I normally run the, let's go ahead and run that other test for a second. Build, let's make sure everything builds. Oh. All right, let's go ahead and run this particular test. That'll populate my database, and I can drag that across. Great. So let's go back to Server Explorer. If I refresh this, there's my tasks table. So what NDBUnit needs in particular is some guidance on how to populate the database. And so it does that using data sets, and that's really simple. I just drag the table across here. Say no to this behavior, because I'm not actually using this as a particular data loading myself. I just need the table itself in there. So with the table in there, what that allows me to do is go ahead and do something really neat, which is write some sample data sets. So let's go ahead and add in an XML file. In this case, I'll call it taskmapfacts.xml, just to make it easy to find. And we'll start off with database. XML ns equals http temp URI. And so now, because it's the XSD generator, I'm actually getting live IntelliSense, if you will, around the database. Need more caffeine. And then I'm getting priority. Now, you got to remember here, this is an enum value. You're writing in the database version. So this is whatever it exists in the database side of things. So in this case, I'll just do 0, but actually this is a high priority. And then if I want to add other rows to the table, I just add another tasks element, and I can add as many as I want. And then if I had dragged more tables there, I can add all the tables that I need and populate all the data I need. So what NDBUnit should be responsible for, and I've got this in my database fixture, is it goes ahead and loads all the sample data. Now again, I just, from a point of time here, I'll go back to the code in a second. I just want to run the test. I've written a routine that looks for embedded resources that have the same name as the class. So just to make it easier to find things. I'm just going to make sure that's an embedded resource. And it loads the data. So every time the test runs, it's going to make sure that entity is there. So let's go ahead and actually go ahead and try and save that. In this case, I'm going to do it as an action, because this is just a slightly prettier way of doing the same thing. So I'll do session.save entity. This is in Hibernate speak. And I'm going to do flush just to make sure it actually does the write to the database. And so using my Fluent behaviors, I'm going to say act should throw the constraint exception, and then transaction.rollback. So that's the theory. Oops, I gotta get this one figured out. Oh. Constraint exception. Oh. Almost out of time here. All right, so let's go ahead and build this up. Run this test. And, oops. Sorry, I've got the wrong schema in here. No, that's correct. All right, I'll just give this one more time. If not, we'll go to the completed example so you can see it in action before you go today. No, all right, we'll go ahead and take a look at the final. I've got a typo somewhere that's causing the namespaces to go out of whack. No problem, we got you covered. So let's go back to my task map here. So here is my various, so there's my use latest database schema, load data, and the duplicate items here. Let's go ahead and just run this test here. And voila, it tested it. Now what I learned here when I was writing this test is I learned a lot about the behavior of my ORM. And again, I would have expected it to throw a constraint exception. That seemed to be the most logical. But what they don't really document, and until you hit these errors, are things like, and Hibernate actually doesn't know anything about system.data.constraint exception. It throws generic exceptions up its pipeline. And so in this case, it actually threw a generic ADO exception, which is an Hibernate one, which was a wrapped SQL exception, which had this particular inner message. So by writing this integration test and testing this constraint, I actually learned a few things about how my ORM behaves in scenarios where I thought it did one thing and it did another. Now, just in the effort of time, I'll just kind of show you the other test where, again, I tested validation. So in this case, I created an object, in this case with a null name, that's not allowed. And again, tested that by saving it, my validator fired and came up with the right message. And then finally, my last integration test was testing that a type conversion worked correctly. So these are a couple of examples of tests that, again, anybody who's using an ORM out there, anybody who's interacting with a service, these are great tests to write because it helps you learn about the behavior of the tool, but also ensure that your services and your dependencies interact appropriately. Yes, you could have read the documentation and learned that an Hibernate throws generic ADO exception, but if you can point me to any developer who can show another developer how to do that in about 5 seconds or less, the documentation out there is not very user-friendly. Versus a test, I can point somebody at a test and say, this is actually how it works. And every developer can hopefully look at this who's written a unit test and say, yep, I see how the interaction between these two components is intended to work, and here's a piece of code that actually validates and proves that it actually does work that way. And so you can think to other scenarios in your particular examples in your applications where this might be the case. So I'm curious, just to kind of get you guys talking, just because I did all the talking, and just to wrap up, while I flip to the slide deck here, if anybody could share with me a scenario where you're like, oh, I wish I had a test for that. I'm looking for horror stories. Anybody looking to volunteer? They got burned in production and didn't have a test for that? What was it? What was the scenario? Yeah. Give me the best.
Integration with sub-service, and when we deploy it to the production server, it simply crashed. Try to write tests, and still it wasn't enough.
Nice.
It was the worst case scenario, which just started working in production.
Service integration, classic. Great. There's a t-shirt. Thanks. Anybody else?